Hello again, this is Mr. Hooper. I'm actually just on here to get this going. I wanted to tell a joke about this restaurant on the moon. It's got great food, but apparently no atmosphere. So hopefully you understand that. Now, we're going to graph absolute value equations and inequalities. I can find the vertex of an absolute value equation. I can also find the domain and range of an absolute value equation. Hold tight on these inequalities. That might be next unit. Not really even sure, but I'll teach you what I know. So, general form of an absolute value equation. This is a little hint of what you're going to do. The shape of it is always this V-looking thing. So it's open, or it always looks like a V. Meaning it's either going to be that way or that way, depending on if it's positive or negative. If it's supposed to say if it's a positive A, then the absolute value function opens up, which would be this example. And if it's a negative A value, meaning this first letter here in front of the absolute, it would open down. So that means we'd have an upside down looking V, like a mountain or something. If it's up, it's positive, like a victory. I don't know. Just cheat a little bit and remember that stuff. Now the vertex. The vertex here is, we used to do this x minus h equals 0 stuff. You add h to both sides. So really, x is equal to h. Basically what that means, the vertex here is always h, comma, k. Alright? That's where the vertex is going to be. It's going to be at those values. Right? So there's nothing flashy here. It's pretty simple, actually, as terms of absolute value equations and remembering a few rules. So determine the vertex of the following function. State whether the graph will open up or down. I think this is really easy. I could write down, 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 down. Let you know a little secret here. A and C are backwards. I would write these are positive. These are going up. Even a half's going up still. It's just not as steep. So the A really just tells you steep. If it's a fraction, it's going to be kind of mellow, like a V like this. If it's really positive, it'll be sharper. Now, I screwed up right away, so hopefully you don't just write everything down I do. Now the rest of this, the vertex would be at 2, 3. This is the h value. It's the opposite the h, or it says minus 2, but it's just the h value here. Here, there is no h value in C, so it would be 0, 7. Here, it's a plus 5, so we would need a negative 5h followed by 0, because there's no plus k there. Then this last one, it would be a positive 3 followed by a negative 5, because there's k is negative. So it's whatever that value is there. So those are a couple examples. Now, to graph these, we're going to determine the vertex. So I would come up here. It's the opposite. So x needs to be negative 1. When x is negative 1, the result of that, or the output, is going to be negative 2. So you place the vertex in the middle of the chart there. Remember, if you didn't like that, you could do the x plus 1 equals 0 thing, subtract 1 from each side, x equals negative 1. How does that happen? This ain't good. I don't know why it froze there. Hopefully it didn't freeze. Please don't freeze later on. I'm not quite sure. I'm not redoing this video. Negative 1. I don't know what's going on there. Alright, then you could do negative 1 plus 1 minus 2, y equals. You'd have y equals 0 minus 2, y would equal negative 2. And so what you should do is on the right-hand side here, really softly, demonstrated how plugging this x equals negative 1 in resulted in me having an output or a y equation. Now what they would tell you to do is choose at least one x value on the other side of the vertex. What I would do is I would choose negative 2 and 0. 0 plus 1 is 1. Absolute value of 1 is 1 minus 2. You're going to get negative 1. So how do I get the values in black? I sub them in here. Negative 2 plus 1 is going to be a negative 1. Absolute value of that is positive. Minus 2 is back at negative 1. So then this negative 1 plus 1 would be 0. Minus 2 is negative 2 again. Oh, I did negative 1. Sorry. I need positive 1 here. So positive 1 plus 1 is 2. 2 minus 2 is going to be 0. I can assume negative 3 plus 1 is negative 2. Positive negative 2. I talk my way into this. Now, if you look at that, that is exactly what we need because we have the same y values on both sides. That allows us to come down here and find 0, negative 1. My vertex is negative 1, negative 2. Then I go even farther, negative 2, negative 1, negative 3, 0, and 1, 0. So when I do an an absolute value equation, I'm going to have this v every time, and it's just going to keep going up by 1, which is good, because that's what my a value here is. That's my slope, or it would go this way. So the domain there, all reals. This is going to go on and on forever. It's going to reach infinity on both sides. The domain, it is never going to get, some people write it like this. Your range, x is greater than or equal to negative 2. It's going to hit negative 2 and just go on and on forever. So a couple of those, I wrote infinity signs on them. I kind of screwed up. You can write it this way. It's a lot easier. Instead of saying it goes from negative 2 to x to infinity, you can just go x has to be greater than negative 2. That means it goes to infinity. For example 3 here, find the vertex first. For the vertex here, I have 4, 1. So I should be able to come over to my graph and graph that if I wanted. 4, positive 1. A little out of sync, but whatever. Now the domain, what I would do is I'd start plugging values in. So I know that I got to find 3. So 3 minus 4 would be negative 1. The absolute value of negative 1 is 1 plus 1 is going to be at 2. So 3, 2. So if I made a little table here, x, y, so I plugged in 3, I got a 2. Alright, if I plug in 2, it'd be 2 minus 4 is negative 2, positive is 2 plus 1 is up at 3. So I'm telling you 2 would be up here at 3. Well, if I check, so 2 is up at 3. If I did 0 real quick, 0 minus 4 is negative 4, which is positive, it'd be up at 5. So 0, 5. So I should be able to see this side is going this way, and it's just going to go up by 1. Domain, all reals. It's going to go on and forever. And x actually, or y here, is just going to be greater than or equal to 1 this time. Because that's the lowest point in your vertex, because that goes positive. If I went back, I think I wrote x is greater than, that should be y is greater than negative 2, because that's what we use for values. Here, pretty similar stuff. So it's the opposite of negative 2, so I'd say 2, comma, negative 4. Alright, my range then is y is greater than or equal to negative 4. So I can already tell you that my vertex is 2, negative 4, so down here on this blue dot, but my value of a is increasing. So that's going to be the lowest point, so it's just negative 4. The domain is also going to be all reals. Right? I know that because there's no special circumstances here, and we could just keep plugging these in. If I went 0, that's negative 2, make it positive, it'd be 0, negative 2 here. 1 would be down here, negative 3. 3 is right there at negative 3. So I don't want to make you spend time, but you have to understand if you plug these values of x's in, you're going to get functions that look like this. And you should practice that so you can graph them on quizzes. Right now I'm graphing them, so it's a little bit easier. Make sure you check your quiz review and you know how to do that. Example 5. This one, I can already tell you that this is going to be a little bit steeper than normal because your a value is increasing here. So your range, y, is greater than negative 3 still works because negative 3 is going to be the lowest spot. The vertex point here is actually 0, negative 3. There's nothing with the x, which tells you that it's going to be 0. Then your domain. Your domain is going to be all reals again. Now, how about graphing it? I would have went to 0, negative 3, made a dot. 1. 2 times 1 is 2 minus 3 is negative 1. If I did negative 1 for x is negative 1. So like if I wrote these out every time, this is what I'm doing in my head. That's going to be a positive 1 after we do that. 2 minus 3 is equal to negative 1. So I would have had negative 1 here. Now, I can tell it's increasing by 2 a little bit. So I'd probably go try in 2. 2 times 2 is 4, minus 3 is 1. So that's up here. So you can see that this is going to go up by 2's every time because my slope is increasing. So that should be a little bit steeper than 1 than we have because all our a values have been 1 so far. Going into example 6, graph the absolute value inequality. Vertex stays the same. It is 2, 5. 2 up 2 over 5. It's going to be about right up here at 2, 5. Alright. Now, it tells me, this little negative sign here tells me it opens down. So I might do like 0. If I plug in 0, I get negative 2. So it'd be 0 minus 2 plus 5. That's actually going to be a negative. If you did this, you get 0 minus 2 is negative 2. The absolute value of negative 2 is a positive 2. However, this negative is out front, so you leave it there. So negative 2 plus 5 is 3. So I need to know that right there is where I'm going to go for x equals 0. So when x is 0, we have a 3. So if I did this again, and I did like 2, or I did like 4, I'd have 4 minus 2. That's going to be 2 again. But absolute value of a positive 2 is 2, except that negative's out front. So it'd be negative 2 plus 5 is 3 again. So that's good. I'm plugging these values in right because it makes that little v. Now, the value of the slope is 1. So then I could just draw this in here. Now, they'd ask a very important question. It is less than that. Now, I would jump to conclusions sometimes, but I'm going to do something for you. I'm going to pick this value here. That value right there is 0, 0. So 0 is less than or equal to negative 0 minus 2 plus 5. Now, I plugged in 0 over here, and I get 3. So that means that I'm going to have 0 is less than or equal to 3. Is this true or false? I think 0 is less than 3, so I think this is a true statement. Less than usually means underneath. I would tell you that since 0, 0 is included, I would have to shade down or below it. And that's going to work that 0, 0 trick, plugging in 0 for x and y here, is what I did in green. y0, x0. You can pick this point, any point under here would satisfy the equation and make it true. Then you want to shade there. If it wasn't true, you would shade on the other side of the line or above it in this example. 7, graph the absolute value inequality. Perfect. We get to do another one of these. Vertex. I see that x doesn't have anything with it. It's going to be at 0, 2. So I come over here, do 0, 2 thing. Now, I'd probably pick positive 2. So negative 3 times a positive 2 is negative 6 plus 2 is negative 4. So I would tell you at x equals 2, we're going to be down at negative 4. Now this is believable because we're going to go down 3, which is what my a value is. To double check, I could do 3 and negative 2 is a positive 6. Oh, if it's a negative 2, it's going to be the same thing. So it'd be positive, negative, it's going to be a 4, 2. So negative 2 down here. We got, what did I say 1 is? Oh, I didn't. This is going to be a negative 1 because of our negative 3. So our negative 3 makes this very steep. Now, through all the chaos, you could still see that 0, 0 is there. So I would just do 0, 0, and I would say 0 is greater than or equal to negative 3 times 0 plus 2. I get 0 is greater than negative 1. This is a true statement. I would shade inside. I'm going to do a not true one. So if I pick this point, this is 4, 0 out here. 4, comma 0. So x is 0, or x is 4. So y 0, 0 is greater than negative 3 times the absolute value of 4 plus 2. I'm confused right now. 0 is greater than negative 12 plus 2. 0 is greater than negative 10. Let's try something else. Let's go to negative 1, negative 5. Negative 5 is greater than negative 3 times a 1 plus 2. Negative 5 is not greater than 1. So we wanted to shade on the outside here. I don't think you can use 0, 0 all the time with absolute value. So don't use 0, 0 because you'll make mistakes sometimes, right? You should have shaded above it, which is why this is greater than, and I shouldn't have confused you there. So I get some points off for that. All right, less than is going to be down. Greater than is going to be above. Now, I checked that to save myself some street cred because of me trying 0, 0. I don't think 0, 0 always works, so we're going to have to talk to some actual math teachers. Hopefully I didn't confuse you too much. Have a great day, and enjoy the rest of your time with your other